Hello, welcome at AVL. My name is Hans van den Heuvel. I'm a specialist for measuring fuel consumption since 26 years, and I started in PLU, then in Peerbook Instruments, and now I work for AVL. Today I want to give you detailed information about our measuring principle, PLU measuring principle delta P like 0. In AVL we are in a good position to have for our fuel consumption measuring and conditioning systems the three main measuring principles. We have the fuel balance, we have the Coriolis principle, and we have the PLU principle. And every measuring principle has different benefits. But today I want to explain the benefits of the PLU measuring principle, the servo-controlled positive displacement meter without any pressure drop. But before we start with this principle, let's talk about the limitation of the regular positive displacement meters.
The conventional positive displacement meter takes the energy from the fuel flow. That means it's driven on by the fuel flow, and the result is you will have a pressure drop above this meter. And if you have a pressure drop here, then a part of the fuel passes this gear without any counting, and this is a leakage, and this leakage is directly a measuring fault. And this measuring fault is not always the same. It changes if the density, the viscosity or the temperature change. And if the pressure from this side is always higher as from this side, then these gears are always pushed in this direction. And the result of it is you will have a higher wearing effect here in these bearings, because it is only on one point, this wearing effect. And if you have a wearing effect, then you have directly a change in the calibration. And conventional positive displacement meters have a very low turn-down ratio, and you cannot measure many different engines, and therefore you have to look for a principle which has a much higher turn-down ratio. And to do not have all this limitation, you can use the PLU principle. And with the PLU principle, the servo-controlled positive displacement meter, we are measuring the pressure drop in the bypass and gives this information to an electronic, and this electronic will give the information to a servo motor, and the servo motor speed up these gears just so much that the pressure drop above these gears is 0. And if we do not have a pressure drop, we do not influence the engine, and we have a lot of additional benefits. And this I will explain on the next picture. If we do not have a pressure drop here, then there is no reason for the fuel to compare anything, and that means this measuring principle is independent of changing in density, viscosity and in temperature. And here with this piston sensing part in the bypass, we have a light source, we have a piston, and we have a photosensor. And the position of this piston is proportional to the fuel flow. That means at 0 fuel flow the piston is in this position and covers the complete light of this light source. If the engine now needs fuel, then the piston goes in this direction and the light comes to this photosensor, and directly the servo motor speeds up and turns these gears. And just in the same way what the engine is using. I give you an example. If you have an engine and the engine is running with 1 liter per hour, then the 1 liter per hour are coming over these gears, and the piston is standing in this position and makes only very small regulation movements. If now the engine needs suddenly 2 liters per hour, then directly the piston goes in this direction more lights comes to the photosensor, and directly the servo motor speed up these gears and increase the fuel flow. And exactly to 2 liters per hour. Because if these gears are having more than 2 liters per hour, then directly the piston goes back in this direction and the servo motor speeds down. This measuring principle is long time stable in calibration, and therefore we have 2 reasons. The first reason is, if the pressure drop here is on both sides the same, then these gears are pushed from all directions with the same power. And that means we do not have nearly no wearing effect here in these bearings. And that is the first reason. The second reason is we are using electronical components, and electronical components will change with the lifetime. But here in this case, if the capacity of this light source change from 100 to 80%, it will directly integrate it by this piston. That means the piston goes in a new working position, and the same light can come to the photosensor. That means this complete delta P sensing part is 0 point stable, and that is the second reason for the long-term stability. And the main part here is, if this meter does not make a pressure drop, we will have absolutely no influence to the engine. And how we come to the results? Now we can say the RPM of these gears are directly proportional to the fuel flow, and on the same shaft where we have the gears, we have a HP encoder, and here we have a frequency output, and this, how many pulses this meter makes per 1 milliliter, that will be calibrated on our certificated test beds. With the PLU measuring principle we have following benefits. No energy is taken from the fuel flow. No pressure difference between inlet and outlet, delta P like 0. No internal leakage flow. And the meter is independent of changes in density, viscosity and temperature. Very important is no influence on the mixture preparation system or to the engine. And we have large measuring ranges with high accuracy and reproducibility, and a turn down ratio up to 1 to 1000. With this principle we have a long-term stability of calibration through nearly no wearing effects. Aging effect of electrical components has no influence to the accuracy, and the complete system is 0 point stable. The accuracy is relating to the measuring value, and we have a high resolution up to 48,000 pulses per cubic centimeter, and this principle is ideal for very small fuel consumption. We start at 0.01 liter per hour. We have a long life cycle. We have meters, they are more than 20 years in the market, and we have a high confidence of the measuring results. We have a right application range. It is for gasoline, diesel and alternative test liquids, alcohol mixtures, and some meters can measure up to 100% methanol and ethanol. This shows a typical calibration report of a PLU flow meter, and very important, this protocol shows that it is traceable to national standards. And what we do is we calibrate from the highest flow point to the lowest flow point. We look for the real pulses for 1 milliliter. And this shows the average KD factor, and you see the individual calibration factors. This makes a curve, and this is a systematical error of the meter and will not change over the lifetime. And if you use it in an electronics, then you work with the according calibration factor, and then we do a linearization and bring every calibration point to the 0 line here. This shows our calibration area for our flow meters and systems, and at this calibration rigs, we are looking for the systematical and for the non-systematical errors of the flow meters. And very important that every values are traceable to national standards. We have excellent laboratory conditions with temperature and humidity control. And every meter and system got its own calibration report. The PLU measuring technology, delta P like 0, is used for following applications. In PLU, high precision flow meters for injector testing, for fuel consumption measurements, then for X-proof measurements and for measuring fuel consumption in a car. And it is used in AVL high precision fuel consumption measuring systems for measuring fuel consumption in the vehicle, for measuring fuel consumption on an engine testbed including temperature control, and for measuring fuel consumption at off-road engines like chainsaws. The delta P like 0 technology is ideal for injection system in research and development and production, in the engine development, in engine calibration, in vehicle testing, in component and system production, and in calibration and service.
Now we are at the end of the presentation. Thank you for your attention, and we hope we see you again at AVL. Thank you and goodbye.